Hello children, we have seen certain definitions of acids and bases and we will see how the acids and bases will ionize and what type of equilibrium they will show. And we know there are two types of acids which are strong acids and weak acids. We know those all things from your lower classes you are studying this. Weak acids are the acids which will not ionize completely. Strong acids are the acids which completely ionize. For example, HCl, H2SO4 and all, they are strong acids. If they dissolve in water, they will completely ionize and form H plus and Cl minus ion. But whereas weak acids, if we take weak acids, they will not ionize so easily. For example, acetic acid and all. So, there are mainly two types of electrolytes, strong electrolytes and weak electrolytes. Strong electrolytes are the substance which ionize almost completely into ions in aqueous solution. If they dissolve in water, they will completely ionize. For example, HCl, HNO3, H2SO4, NaOH, KaOH, NaCl, KNO3, etc. These are strong electrolytes. A weak electrolyte is a substance which ionizes to a small extent in aqueous solution. It will not completely ionize, whereas a certain limit only it will ionize. For example, acetic acid. Its formula is CH3COOH. And if you take CH3COH, it's a weak electrolyte. When it dissolves in water, what will happen is it will not completely ionize. It will ionize in the form of CH3COO minus. Then it will combine with water and it produce H3O plus. So in these type of electrolytes, and equilibrium exists them, that is ionic equilibrium. So after some time, a dynamic equilibrium will be established after some time between the ions produced ionization and the unionized molecule. This is called ionic equilibrium. Thus, ionic equilibrium is the equilibrium established between the unionized molecule and the ions in solution of weak electrolyte. These things you have to keep in mind before starting this. And we can identify the degree of ionization or dissociation and how much extent it is ionized. So it is given by the formula degree of dissociation is equal to number of molecules of the electrolyte that ionize divided by total number of molecules of the electrolyte. That we will see how to solve the problems and all. Okay, so before that we will see the ionization of acids and bases. So we know there are two types of acids, stronger base, weak acid, weak base. Always the stronger acid donates a proton to the stronger base. Stronger acid donate proton to only stronger base. Strong acid dissociate very easily. That we have seen because it's a strong acid can easily dissolve in water and ionize. So it form a weak base. If a strong acid dissolved in water, it will give its weak base. So always strong acids have weak conjugate base. So there is a pair. The pair is like strong acid, weak base. Such pair is known as conjugate base. That is strong acid, weak base, conjugate pair. For example, perchloric acid, hydrochloric acid, nitric acid. These are very strong acids. And we'll move to the weak acid. Weak acids have very strong conjugate base. Examples are hydrofluoric acid and acetic acid. These are weak acids. So children, you have to keep in mind there are strong acids and weak acids. Whenever a strong acid dissolved in water, it will give its weak base. That is acid base conjugate pair. Then we'll see what is the ionization constant and ionic product in these cases. In pure water, one water molecule donates proton and acts as an acid, and another water molecule accepts a proton and acts as a base. That we have seen, water can act as both acid and base. So for example, if you check here, so we have already said that we can consider both acid as an both water as an acid and base. So if in water dissociates, if we know in a substance there are a lot of molecules. If we consider two water molecules, it will dissociate in the form H3O plus plus OH minus. So here H3O plus, it is acid, this one is base. So its equilibrium constant. How can you write the equilibrium constant? Rate of the concentration of the product divided by concentration of the product divided by the reactants. This all we have seen. So like this method we can write the equilibrium. So the concentration of water is omitted from the denominator as water is a pure liquid. We know water is a pure liquid, so its concentration always remains constant. So we can omit from the denominator. And if we see the equilibrium, so there will be only the equilibrium constant of the products. So water is incorporated within the equilibrium constant to give a new constant Kw, which is called the ionic product of water. This Kw is known as ionic product of water because it is the equilibrium constant of water. So it is known as ionic product of water. So what is ionic product of water? It is concentration of H plus ion and OH minus ion. So we can distinguish acidic, basic and neutral solution by their relative values of H3O plus and OH minus concentrations. So we are comparing all the values with the water concentration. So if it is acidic, H3O plus having more charge, the concentration of H3O plus is greater compared to OH minus, then it is acidic. If it is basic, what will be more? OH minus. If it is neutral, concentration of H3O plus and OH minus will be equal. We'll see ionization constants of weak acids. How we can calculate the ionization constant? How much they will ionized? What's the extent of their ionization given by the formula ionization constant? So general formula for dissociation of weak acids is given by the formula is K alpha is equal to K is equal to C square alpha square divided by C into 1 minus alpha. Or we can write it as, if we solve the general equation, and if we cut the general values, we will get the formula C alpha square divided by 1 minus alpha. So here Ka is the dissociation or ionization constant. So at a given temperature T, Ka is a measure of the strength of an acid. Hs, that is, larger the value of Ka, the stronger is the acid. If Ka value is larger, then the acid will be very strong. It is a dimensionless quantity. It has no dimensions. So the pH scale of hydrogen ion concentration has been extended to other species and quantities. How can we identify the pH? If we take the pH, there are two pH, pH of hydrogen ion and pH of OH minus ion. From that we can calculate whether the acid is strong or base is strong, etc. So how we can calculate the pH? The species present before dissociation are identified as Bronsted Lowry acids or bases. These all things we have studied. And balanced equations for possible reactants, that's when a species acting both acid as well as base were written. And then the reaction with higher ionization constant is identified as the primary reaction. Then enlist in a tabular form. Then find out initial concentrated, change in concentration into equilibrium in terms alpha, that is degree of ionization, and equilibrium concentration that we will solve in the problem cases. So substitute equilibrium concentration into equilibrium constant, equation for principal reaction and solve for alpha. So calculate pH by the formula pH of log concentration of H plus. For this we need to know the log values. So this is the order of acid strength. Most strongest acid is iodic acid, then chlorous acid, the hydrogen peroxide. These all are considered as acid, but they are very weak acids. This is the basic strength. Aniline, pyridine, these are lowest. Diethylamine is the most basic. These are calculated by in the basis of ionic equilibrium and the pH. Acid base strength. Strong acids are completely dissociated in water. That are strong acids. For example, HCl, H2SO4, HNO3. Here you can see that. So here bases. If this HCl dissolved in water, it will dissociate in the form of H plus and Cl minus. So H plus and Cl minus. So Cl minus is the conjugate bases. We can negligible these bases because they are very weak compared to acid. These are weak acids. These are negligible acids. So weak acids only dissociate partially in water. So their conjugate bases are weak bases. Then acid and base strength. In any acid-base reaction, the equilibrium will favor the reaction that moves the proton to the stronger base. Any acids which favor the reaction towards the stronger base, then only then we can calculate the acid-base strength. For example, here HCl plus H2 are taken. If HCl dissolved in water, it will dissociate in the form of H3O plus Cl minus. So H2O is a much stronger base than compared to Cl minus. So this is acid, this is base. Here also it is acid, it is base. So if we compared H2 and Cl minus, if we compare the acidic strength, H2 is more basic strength. H2 is more basic compared to Cl minus. So the equilibrium lies so far to the right. So equilibrium lies to the so far to the right, not to here. So in this position only equilibrium favors. So K is very much greater than 1. Then we'll see ionization of weak bases. The equilibrium constant for base ionization is called base ionization constant. For acid, it is acid ionization constant. And it is represented by the letter Kb. For acids, it is represented by Ka. Alternatively, C is the initial concentration of base and alpha is the degree of ionization of base. So we'll see how to calculate this. It is calculated by the formula C alpha square by 1 minus alpha. So we'll see what are the relation between Ka and Kb. We know Ka is the acid dissociation constant, Kb is the base dissociation constant. So the equilibrium reaction constant for the net reaction obtained adding these two. So in case of conjugate acid base pair, K net is equal to K1 into K2. That is Ka into Kb is equal to Kw. So pK into pKb, in the case of pressure, pK into pKb is equal to pKw, that is equal to 14, that we know. Because for a neutral solution, it will be 14. Then in the case of di and polybasic acid and di and polyacidic acid. We know some acids like oxalic acid, sulfuric acid, phosphoric acid have more than one ionizable proton, because we know in sulfuric acid there are 2 hydrogen ions, so it can give 2 hydrogen ions. So it is a dibasic acid, because if it is dissolved in water, it can donate 2 H plus ion. Similarly, tribasic acid, that is it can donate 3 H plus ion, so it is a tribasic acid. In the case of such acids, what we can do? Higher order ionization constant are smaller than the lower order ionization constant. Hence, it is difficult to remove a positively charged proton from negative ion due to electrostatic. There will be electrostatic force of attraction. Then polyprotic acid.